All right, welcome to a brand new explainer. Today we're tackling what is undeniably the absolute behemoth of our era, artificial intelligence. Everywhere you look right now, there's just relentless hype, doomsday panic, and these breathless promises. But today we're going to cut right through all of that noise. We're strictly looking at the mechanics of how this tech actually works, unpacking its undeniable real-world impact, and confronting the massive dilemmas it presents to society.
Because, let's be real, sitting right beneath the surface of all those awe-inspiring demos and soaring tech stocks is this massive question. Are we losing control of our own creations? It's the ultimate lingering anxiety so many of us have about AI. When you start building systems that can independently learn and act to maximize their goals, well, the stakes get incredibly high. It immediately hooks us into wondering what exactly it is we've built.
And if you want to grasp the sheer, unstoppable scale of what we're dealing with, just look at this number, $2.7 trillion. A recent report estimated that by 2030, this staggering amount is going to be invested into AI infrastructure and data centers in the US alone. To put that into perspective, that level of spending surpasses the budget of the World War II Manhattan Project every single month. We are witnessing an industrial mobilization literally unlike anything in modern history.
So, here is our roadmap for peeling back the layers of this colossal topic. We'll start with decoding AI's history, move into how machines actually learn, explore AI in the real world, tackle the ethics and risks, and finally, look at the future of machine minds. Let's get into it.
Section 1. Decoding artificial intelligence, from theory to the modern boom. To understand the frenzy today, you've kind of got to see where it all started. And surprise, this isn't a new concept at all. The field of AI was actually founded as an academic discipline way back in 1956 at a Dartmouth College workshop. Back then, researchers were super optimistic, predicting machines would match human intelligence within a generation. But they vastly underestimated how hard that would be. Computers just lacked the power, leading to what we call AI winters in the 70s and 80s, these long stretches of disappointment and totally lost funding. It wasn't until 2012 that things exploded. That's when GPUs, or graphics processing units, accelerated a technique called deep learning, blowing past all previous methods. And that laid the groundwork for the 2022 generative AI boom that completely changed the world.
Okay, moving on to Section 2, how machines actually learn, the mechanics hidden beneath the surface.
You hear these terms thrown around constantly by tech companies. Let's demystify that jargon right now so you know exactly what's happening under the hood. At the very foundation is machine learning. Unlike traditional software, where a human programmer has to write a hard-coded rule for every single action a computer takes, machine learning takes a totally different approach. These are programs designed to improve their performance on a task automatically. You aren't programming the solution, you're programming the machine to learn the solution from experience and data.
What's genuinely fascinating is how that learning is actually structured. Enter the artificial neural network. It's a collection of interconnected nodes that loosely model the neurons in a biological human brain. When data comes into the network, each node applies a function. If the weight of that data crosses a specific threshold, boom, the signal transmits to the next layer, helping the machine recognize complex patterns.
Now, when you stack a bunch of those layers together, you get deep learning. This is where the magic really happens. Multiple layers allow the system to progressively extract higher-level features from raw input. Think about it like processing a photograph. The lowest, earliest layers of the network might only spot simple edges and curves. The next layers recognize textures, and the highest layers assemble all of that together to identify a highly complex concept like a full human face.
And this brilliantly illustrates the two main pathways of how we actually teach these models to make sense of the world. On one hand, you have supervised learning, where researchers feed the AI data that is already labeled with expected answers. Think thousands of photos explicitly tagged as cats, because, what else is the internet for? On the other hand, unsupervised learning unleashes the AI on raw, unlabeled data streams, forcing the system to find hidden patterns and structures entirely without human guidance.
Section 3. AI in the real world, from chessboards to healthcare.
So now that we know the mechanics, how do these models actually show up in our lives? Well, the reality is, you're already deeply embedded in the AI ecosystem. You interact with these algorithms every single day. When you use a search engine, when Amazon or Netflix eerily recommend exactly what you want, when you talk to Siri, or even when your phone unlocks using facial recognition, you are relying on machine learning classifiers and neural networks. AI isn't just the future, it's literally the invisible infrastructure of the present.
But the evolution of its capabilities is what's truly breathtaking. In 1997, the big milestone was IBM's Deep Blue beating human world champion Garry Kasparov at chess. Impressive, for sure, but it was a perfect information game with fixed rules. Fast forward to 2021, and an AI named AlphaFold 2 successfully approximated the 3D structures of proteins in mere hours, instead of the months it used to take human scientists. We moved from conquering games to solving massive, immensely complex biological mysteries. Section 4. Ethics, Risks, and Harms, the massive dilemmas we face.
Of course, with unprecedented leaps comes some pretty severe complications. AI presents a massive spectrum of ethical battlegrounds that society is currently scrambling to regulate. We're looking at companies scraping unlicensed copyrighted work and private data just to train their models. We're seeing dangerous algorithmic bias. We are facing a massive environmental toll on our power grids. We're dealing with automated deepfakes and the overwhelming centralization of power by just a few big tech giants.
Consider just the immediate threat of misinformation. AI pioneer Geoffrey Hinton recently offered a pretty stark warning about this, noting that modern AI is incredibly good at persuasion. He asked, suppose you wanted to invade the capital of the US. Do you have to go there and do it yourself? No, you just have to be good at persuasion. It highlights the profound objective threat of AI-generated misinformation, its ability to seamlessly manipulate human belief using deepfakes and computational propaganda.
Then there's the incredibly complex issue of algorithmic bias. Take Compass, for example. It's a commercial program widely used by U.S. courts to assess if a defendant might reoffend. Well, an independent study found this wild mathematical dilemma. While the system was calibrated to an equal 61% general error rate for both white and black defendants, the actual types of errors were completely different. The system consistently overestimated the chance a black person would reoffend and underestimated the chance for a white person. It imparts a vital lesson. Algorithms can and do inherit our historical biases from the data they train on. Math does not automatically mean fairness.
And then there's the physical cost. What does this massive computation actually mean for the grid powering your home? Well, the data indicates that a single ChatGPT search uses 10 times the electrical energy of a standard Google search. Just think about that for a second. 10 times. That massive consumption translates into a harsh environmental reality. In 2022, data centers consumed 3% of U.S. power. By 2030, that forecast jumps up to 8%. Tech companies are so desperate for electricity to feed AI's hunger that Microsoft recently announced an agreement to literally reopen the 3 Mile Island nuclear power plant. That is the sheer physical footprint of the AI boom. Finally, Section 5. The future of machine minds. Where is humanity heading? To understand our ultimate trajectory, you have to realize that currently, everything we interact with is narrow AI. It's great at specific, isolated tasks, playing chess, translating languages, generating images. But that's not the endgame. Tech companies are heavily investing to achieve AGI, or Artificial General Intelligence. This is the holy grail, a machine mind with human-level versatility, capable of completing virtually any cognitive task at least as well as a human.
Which leads us to one final provocative thought. As developers inch closer and closer to AGI, this major philosophical debate is unfolding. Alan Turing noted long ago that we define intelligence by external behavior. But if a machine perfectly simulates the human mind, if it speaks, reasons, and acts exactly like us, does it actually matter if it's just software on a server? Does simulating consciousness ultimately become indistinguishable from actually having it? It's a fascinating, complex dilemma to leave you with. Thanks so much for joining us for this explainer. Keep questioning, keep learning, and we'll see you next time.